Today we're going to be taking a look at domain and range from graphs, and when we write our answer we will be writing our answers in interval notation. Okay, so as you recall, the domain of a graph is going to be all of the x coordinates. So in other words, we're going to look left to right along these graphs along the x-axis to determine our domain. Alright, so let's go ahead and put an x underneath there. Alright, and then for range, if you recall, that's all of the y values, so we will be looking up and down the y-axis to determine the range. Alright, so y-axis there. Alright, in this first example, okay, this should look like a familiar base graph if you've memorized your family of functions. Alright, this is the y equals 1 over x squared graph. Okay, now looking left to right across the graph to try to determine my domain. Alright, the farther to the left here we go, negative infinity is going to be sitting out here, positive infinity is going to be sitting out here. Okay, now knowing the basic shape of this graph, alright, it makes the x-axis in both places a horizontal asymptote because the graph gets really close to the x-axis but does not ever touch it. Okay, same thing over here at positive infinity, and also along the y-axis turns out to be an vertical asymptote as well because the graph will come up and get really close to it but never touch it. Okay, so knowing that, if I'm going left to right, so how far to the left is the graph going to go? Well, it's going to go all the way out to negative infinity. Alright, and then as I come left to right across the graph, I'm going to be approaching 0, but it's going to get really close to it, but it's never going to include 0, so 0 is not going to be in the domain. Alright, it will pick up after the 0 because it gets infinitely close on the right hand side. Alright, but does still again does not touch 0, and then the graph will continue on to the right to positive infinity. Alright, so if we were going to write that in interval notation, alright, if you recall in interval notation, negative infinity and positive infinity always has curly brackets. So we will start at negative infinity. It's going to get really close to 0 but never touch it, so it has to be a curly bracket on 0 because we're not going to include it. Alright, now we are going to pick up on the other side of 0. So I'm going to use a union here. Again, curly bracket because I do not want to include 0. And then it will go all the way to positive infinity. Alright, so there is your domain for that one. Alright, now looking at the range. Okay, now range is my y values, so I'm going to be looking up and down this y-axis. Alright, and I always want to start with my lowest y value and go up to my highest y value. Alright, so there's nothing down here. Alright, so there's no graph or anything down here, so I know it's not going to be negative. Alright, now if this is approaching this as an asymptote, then it's going to get really close to 0 on the y-axis, but again, never ever touch it. So the lowest value there is going to be 0, but curvy brackets because it's not going to include it. Alright, and then since they both go up and up, alright, then it's going to go up to positive infinity along the y-axis. So again, alright, if you need to see it, there is a positive infinity up there, there's a negative infinity down here as well. Alright, the graph is going to, along the y-axis, go up to infinity, getting infinitely close to the y-axis, never touching it. Okay, so again, I would have an infinity here and curvy brackets. Alright, so that takes care of our first one. Alright, now for our second example here, I think I'll start with domain again. Okay, so along this left to right x-axis here, alright, I do not have arrows on the ends of these, but I also don't have solid dots. So when I draw a graph like that, I'm meaning that it goes on forever and ever in that direction. Okay, now, yes, this does appear like it's going down, but as well as going down, it's also going to the left. Okay, so it is forever and ever getting farther and farther to negative infinity along my x-axis. Alright, with positive infinity being over here. Okay, so the farthest left value there is going to be negative infinity. Alright, now as I come to the right, I follow the function up and it gets to negative 3. Alright, but I have an open dot there. Open dot meaning it does not include that value, so I have a negative 3. curvy bracket because I am not going to include that. Alright, now I'm going to come up here and I'm going to look at the rest of this function over here. Okay, I have another open dot here at -3, so the value of -3 is not included in this graph at all. Alright, but then going all the way across here on my x-axis, it's going to stay and go all the way up to positive infinity. Okay, so I'm going to do union, curvy bracket, -3, all the way to positive infinity. Alright, taking a look at the range. Alright, again now I've got to, let's go ahead and label negative infinity down here, positive infinity up here. I want the lowest y value. Now this part of the graph, alright, yes, it is going really far to the left, but it is also at an angle, so it is also going down. Alright, so the lowest value that this graph will reach on the y-axis is negative infinity. Curvy bracket, negative infinity. Alright, now it's going to come up, and how high along the y-axis is it going to come up to? Well, it's going to come up to 2, but again, not included because that's an open dot. So I'll put a 2 here with a curvy bracket. Alright, now I've got a jump here. Alright, so 3 and anything in between 2 and 4 here is not included in the graph at all. Okay, so the next value going up that is included is going to be 4, and that's the only value that's included. If I'm thinking going up the graph, I've got all the numbers on the y-axis from negative infinity all the way up to 2, and then I also have to include 4. Alright, and so since I am going to include 4, I'm going to go square brackets around that 4. I do not have an interval, alright, because it's a single y value going up right there. Okay, so that takes care of domain and range for that graph. Alright, now let's take a look at this third example. Alright, starting with domain. Alright, left to right across the graph. Now this one, I did put a definite solid dot there. Alright, so this segment right here does not go on forever and ever in either directions. I have a solid dot here, I have an open dot here. Alright, looking left to right across the graph here, it starts at a -4, but because it's a solid dot, then I need a square bracket around the -4 to say I am including that in my graph. Alright, and then how far right along the x-axis does it go? Well, it goes till I get to -2, which is an x value. Alright, but here again, open dot, I'm not including that -2. Alright, now there's a jump right here. Alright, so I've got another section of the graph that I have to look at. Alright, left to right across my graph, this segment right here is starting at 1, but it's an open dot, so I do not include it. So it's a curvy bracket and 1. Alright, and then how far to the right does it go? Well, over here is positive infinity, and that's going to go on forever and ever and ever. So this will be a positive infinity curvy bracket. Alright, now for the range, you want to think up and down the y-axis, and you want to start with the lowest value. Alright, so up and down here, okay, lowest value on this graph is going to, lowest y value on this graph is going to be a -3, and it's going to have that closed dot there, so I have to include it, -3. Alright, and then how high up does it go? Well, it goes all the way up until 1 on the y-axis, open dot, so it'll be curvy bracket. Alright, again, I have a jump, so I will do my union symbol. Alright, now where along the y-axis does it pick back up? Well, it picks back up at 5. Alright, but again, open dot, so I do not include it. And then it again, yes, it is going to the right, but it's at an angle, so not only is it going to the right, but it is also going up the graph to positive infinity up here. So then it will continue on to infinity with a curvy bracket. Alright, so 3 examples of how you can look at your graphs and determine your domain and range by looking at your x-axis and your y-axis. Thanks for watching.